Welcome to this video on Chemistry Paper 1 Revision. Take a moment to look at the images on the slide and name the topics they represent. This video covers revision material for the science mock, specifically focusing on Chemistry Paper 2 content. Let's review atomic structure. Atoms are composed of protons with a +1 charge and mass of 1, neutrons with 0 charge and mass of 1, and electrons with a -1 charge and negligible mass. Isotopes are atoms of the same element with the same proton number, but different neutron numbers. Here we see two isotopes of hydrogen. In the Bohr model of the electronic structure of the atom, electrons are arranged in shells. The maximum number of electrons on the first shell is 2, and on the second and third shells, it is 8. The modern periodic table organizes elements into groups, which are columns, based on how they react. Groups indicate the number of outer shell electrons. Periods are the rows. Element symbols contain two numbers. The smaller number is the proton number, which also equals the electron number. The bigger number is the relative atomic mass, which is the number of protons plus neutrons. Simple covalent bonding occurs between two or more nonmetals. A covalent bond is a shared pair of electrons, forming simple covalent molecules. Chlorine is a gas at room temperature due to its low boiling point. This is because, as a simple covalent molecule, it only has a few weak intermolecular bonds or forces. Diamond and graphite are giant covalent structures, both made of carbon, which are allotropes. They have high boiling and melting points due to many strong covalent bonds. Diamond melts at around 4,000 degrees Celsius. Graphite is a form of carbon found in pencils. Since graphite is arranged in layers with free electrons between them, it conducts electricity. Because the layers in graphite, graphene, and other carbon allotropes can slide over each other, they are excellent industrial lubricants. Giant ionic bonding happens between metals and nonmetals. The metal element transfers its outer shell electron or electrons to the nonmetal, forming positive and negative ions. All ionic molecules are giant structures. Since ionic molecules are giant, they have high melting and boiling points. The ions can move when melted or dissolved in water, allowing ionic compounds to conduct electricity in these states. Metallic bonding occurs between metals, forming giant structures. Each metallic element loses electrons to create a quote, sea of delocalized electrons, leaving the metallic elements positively charged. Metallic bonding results in high melting and boiling points due to strong bonds. Metals also conduct electricity because of free-moving electrons. Activation energy is the minimum energy needed to start a chemical reaction. For some reactions, room temperature heat is sufficient to provide this energy. Reaction profiles illustrate energy changes. Exothermic reactions release energy into the surroundings, causing them to heat up, as the chemical reactants lose energy. In an exothermic reaction profile, the initial hump represents the activation energy, and the difference in energy between reactants and products is the energy change. Endothermic reactions absorb energy from their surroundings, making the surroundings colder as the chemical reactants gain energy. The first hump still represents activation energy. Formulations are mixtures where the precise amounts of each chemical are known. Common examples include inks, perfumes, and cosmetics. Paper or thin layer chromatography involves two parts: a stationary phase that doesn't move, like the paper, and a mobile phase that moves, like the solvent water. Chromatography separates mixtures, and the RF value is used to identify chemicals. It is calculated as the distance of the component divided by the distance of the solvent, measured from the pencil line. This slide provides information on balancing symbol equations and calculating formula mass, key concepts for stoichiometry. For higher tier, a mole is a measure of the number of atoms or molecules in a mass of a substance. The number of moles equals mass in grams divided by the relative formula mass. Concentration measures how closely dissolved molecules or ions are packed. For higher tier, concentration equals moles divided by volume, with units of moles per decimeter cubed. Strong acids fully separate into hydrogen ions in water, while weak acids only partially separate. This distinction is crucial for understanding acid behavior. pH can be measured using indicators or electronic probes. It measures the concentration of hydrogen ions. Diluting a solution tenfold increases the pH by 1. Titrations determine unknown solution concentrations by neutralizing an acid or alkali using a known solution and an indicator. Consistent titer results are needed for precision. For higher tier, pH curves visualize the neutralization point of a titration. The steepest gradient indicates the neutralization point, and the shape depends on the acid and alkali strength. Salts are formed through 3 main reactions: metal plus acid, acid plus alkali, and metal carbonate plus alkali. Each reaction produces a different set of products. Hydrogen gas is identified using the quote squeaky pop test. Hydrogen reacts strongly with oxygen when ignited, creating a small explosion and a distinctive sound. Hydrogen is released in the reaction between an acid and an alkali. The conservation of mass states that the mass of reactants equals the mass of products in a chemical reaction. This is why chemical symbol equations must be balanced to reflect the same number of atoms on both sides. Remember the acronym OILRIG. Oxidation is loss of electrons, and reduction is gain of electrons. Oxidation also involves gaining oxygen, while reduction involves losing oxygen. For higher tier, half equations show the transfer of electrons. Oxidation involves the loss of electrons, and reduction involves the gain of electrons. Full ionic equations combine these, canceling out the electrons. Electrolysis separates elements from compounds using electricity. Cations are positive and go to the negative cathode. Anions are negative and go to the positive anode. In the electrolysis of an aqueous solution like lithium bromide, the least reactive metal or hydrogen forms at the cathode. The most reactive non-metal or halogen forms at the anode. In science, variables are categorized as independent, dependent, and control. We change the independent variable, measure the dependent variable, and keep control variables constant. For example, in a chemistry experiment, the independent variable might be the concentration of hydrochloric acid, and the dependent variable is the volume of gas produced. To calculate the percentage of an amount, multiply the total amount by the percentage divided by 100. This is a crucial math skill for science calculations. This final revision slide displays many of the concepts we've covered, from reaction profiles to the periodic table and bonding. Review these images for a quick recap. Thank you for watching this revision video. Good luck with your exams!